innovation that we have been continuing for over a year now in our organization. The purpose is to apprise you about maybe one of the emerging technologies, and then its implementation can be accelerated in our organization. The participants profile that we have envisaged is both leadership roles who are in the rank of CGMs and executive directors, and with them are the young mentors. So reverse mentors who would be helping them understand this topic over the next 1 month, and so that they are at least aware about the basic nuances, potential applications, the use cases of these technology. So on that note, let me invite Atanu Mukherjee sir, who is head of academics, CHRD and IT at MTI, and has been driving lot of L&D initiatives in our company. To kindly welcome the participants, welcome our subject matter expert, as well as the team members from NASSCOM. Atanu Mukherjee sir, please.
Thank you, Chandran. First of all, I like to welcome Shuleka De ma'am and Neeraj Mani Saab. Right, and as far as I know, Shuleka ma'am, whatever information I have got, she is expert in this particular area of industrial Internet of Things. And Madam is also the Chief Executive Officer of NASSCOM and also subject matter expert also. And she is the co-founder and the CEO of Things Alive Solution Private Limited. And very recently, I came to know that she is from Durgapur. And right now, I think just 1 hour before, I have returned from Durgapur steel plant. So it's nice to hear from you. And also, I like to welcome all the executive director and the chief general manager of Steel Authority of India Limited. As you can see the attendance, of course, there is some review meeting of Chairman Saab is also happening simultaneously. So some of the key EDs and CGMs, their presence are not here. But otherwise, very religiously, we have observed that they are also attending this knowledge bite session. To tell you in short, already the objective of this knowledge bite session is to update with the emerging technology, both the mentor as well as the mentee. And this has proved very well because to take up the reverse mentoring process forward in cell. We have seen that the young mentee, young mentor, they are also updating their knowledge and skills in the emerging technology with the support of these knowledge bite forum. And similarly, our senior people at the mentee level, they are also getting a lot of benefited and with the all emerging technology. Just to brief the house and just to remind you, this is the 18th episode we are conducting right now, and very religiously Mr. Chandranath is driving this knowledge bite session every first Saturday of every month. He is driving this, and just for your information, we have conducted the knowledge bite session on chat GPT, social media, digital arrays, cloud computing, blockchain, etc. And today we'll be discussing about the industrial Internet of Things. I don't want to speak much before Shuleka ma'am on this industrial Internet of Things, but little bit of information, whatever I learned from Chandranath, I can share with you. This industrial Internet of Things, basically it is the integration of the connected sensors. As already all CGMs and EDs, they know that in our plant area, lot of sensors are there at different places. So this IIoT gives the integration of these connected sensors, devices, and the advanced analytics within the industrial environment. This IIoT also enables the real-time data collection, communication between the machine system and the people. And in the process, it builds upon the traditional automation system by adding layer of connectivity, cloud computing, and data-driven intelligence, and driving transformation towards smart factories and Industry 4.0. So this is a little bit of knowledge. I am not at all expert, and I don't want to open my mouth further before Shuleka ma'am and Neeraj is also connected from NASCOM. So with this, I once again welcome Shuleka ma'am and Neeraj and all the executive directors and the CGMs who are connected today online. Welcome all. Thank you. And now I hand over to Sri Chandana to take the things forward.
Thank you. Thank you very much, sir. Indeed, actually, this is a wonderful occasion, and you have given a background about the Knowledge Byte session, but it is only apt that I introduce our speaker for today's evening. I hope my screen is visible that I have shared, if somebody can confirm.
Yes, yes.
Yes, fantastic, fantastic. So we have with the pleasure of having Ms. Sulekha Day. She is, I'm sure you can as obviously see a vibrant and dynamic personality in the industry. She is co-founder as well as CEO of Things Alive Solutions Private Limited, and one of the, as Neeraj sir said, that one of the stalwarts subject matter expert in the domain for NASCOM. So with over 15 years of experience before founding and becoming CEO, she led large scale SAP programs at Wipro, and then her passion for bridging the physical systems with intelligent software has laid the foundations for Things Alive's organization. Just to give you a background about Things Alive Solutions Private Limited, this is actually working towards AI-powered IoT hardware, embedded systems, cloud platforms, enterprise integrations, and they are doing a lot of activities with a focus on sustainable innovation, Industry 4 enablement, and global collaborations. So on that brief introduction, I'm going to welcome her. Along with Madam Sulekha, we have Mr. Neeraj Mani as well. Neeraj Mani is actually driving the collaboration with public sector enterprises. He has a lot in his plate, but he has been giving a big slice of that time for Steel Authority of India Limited. So I'm really grateful for his collaborations and his passion for seeing that technology goes through a lot of public sector organization, and his commitment towards the Steel Authority of India Limited. So really grateful to Neeraj Maniji as well for joining today's session. On that note, let me invite Madam Sulekha Day to take forward today's interactions. Ma'am, please.
Thank you, everyone. I hope I am audible.
Yeah.
Yes, you are audible, very much.
Audible, yeah.
Thank you, Vadanu sir, and thank you, Chandra sir, for the introduction. And I'm really glad to be as a trainer for industrial IoT for Excel. And I look forward that if you have any questions during the sessions and throughout the sessions, please just feel free to ask me. Okay. So I'll share my screen. I hope my screen is visible.
Yes, it's visible.
Yes, it is visible. Yeah.
So, so I have been working. We started the Things Alive 2019. So as you see, Things Alive. So we are work normally all the things, and we're making it alive basically. So we do a lot of connected things. We work on the sensors, parameter, understand inside of machineries for different industries. So in this training, I think my introduction is already been given. So thank you so much for that. Yeah, I will proceed further.
एक तो दिन भेजा था ना, मंथली प्रोग्राम करता है.
Yeah, I would request all of you to kindly keep your mics on the mute mode.
So this
Yes,
is overall agenda of the session. I will walk you through about IoT sensors, different parameter data collection that we normally work for industrial IoT 4.0, and how the communication module work with the IoT devices, how different industrial protocol required to be implemented on IoT devices. We'll also walk through of some of the use cases that is quite widely being used in manufacturing and different plant OT and IT kind of combination segment where we can leverage the understanding about IoT in terms of use case implementation. So this is overall agenda, and yeah, during the agenda or at the end of the agenda, feel free to ask me questions. No problem on that. So I will take it forward as an introduction of IoT. We call it IIoT, Industrial IoT, Internet of Things. So how globally the Internet of Things has been changing different communication mode with different as well as planned from ground level to the remote system level, everything is changing. To give you a little bit brief about IoT, IoT is not started 2025, right? IoT started back probably in 18th century, where different different automotive or manufacturing segments started talking to each other in terms of understanding and analyzing the electronical modules. So what is industrial IoT, right? Industrial IoT will help you to analyze machinery's data um, in not only in the application level, but in remote system level as well. So we call it IoT, Internet of Thing, and we call it IIoT, which is an industrial IoT, which industrial IoT gives you much more deeper integrations on your IT systems, cloud, as well as different communication module segment. In terms of the overall value system, if you see, it not only gives you the real-time data analysis, but it gives you a lot of historical parameter of your machineries. Let's talk about in a plant, right? Uh, a boiler continuously running on a certain temperature on a particular area, right? The time duration, the temperature throughout 5 month or 5 year or even 15 year, how it has been increasing or performing some changes throughout the environment, throughout different modules, everything you can monitor via IoT, via sensors. So it gives you real-time insights. Also, it gives you a lot of historical parameter by industrial IoT sensors, right? So when you call it sensors, this is widely couple of sensor I just pull out from the industrial segment, like proximity sensor. You call it magnetic sensors or capacity, or different laser sensors, or environmental different temperature sensors, ambience temperature sensors. All these are rugged IP and EMI proof sensors that has been widely used in industries, in plant. Um, Now, if you talk about these sensors, it gives you data, whether it's analog data or digital data. It gives you certain amount of data. Sometimes these data are not connected to the IT systems, right? So right now, if you can talk about sensors, it's not only the sensors, but it can also connect with different mechanical parts as well, right? For example, motors, right? Or any kind of valve, actuations, right? So there are a number of actuators that can handle a kind of call based on certain sensor parameter, right? So we can develop certain use cases on industrial IoT based on this sensor parameter and edge computing to give certain filtrations on this data point, that can come from the sensors, and even you can take a trigger to call some actuation bulb to on and off. Let's say some of the temperature goes certain level high, more than 180 degrees, so that the valve should always open and it should give an alert, right? So this kind of, I'm sorry.
Yeah, I think I would request participants to kindly keep your mics on the mute mode. Yes, ma'am. Sorry for that.
Yeah, it's okay. So I'm just giving some of the example of industrial sensors and the edge devices that widely been used in the plant. But yes, IoT means communication with those sensors and talking to those sensors. So how are we going to communicate? So there are certain protocol that helps you to communicate those communication module like MQTT, HTTPS, COPA. These are the different way of modern way to communicate, call a protocol to sync the data into a system, right? Along with that, you need certain network as well, right? So you need a complete bandwidth and network protocol to maintain those parameters. You also need a kind of wireless medium or Bluetooth or as a 5G or Wi-Fi or even LoRa kind of network where you don't have any kind of internet communications. For example, a mining area, right, where you don't have any internet communication. You can set up LoRaWAN that create a kind of internal network and to talk to each other. So we call it LoRaWAN. It's a module. You also have a Zigbee to communicate different sensor data. As you know, you have Wi-Fi that mostly sends the data between HTTP and MQTT protocol. And we have been working on 4G, 5G. Right now, some of the telecom provider is also working on the 6G module. For example, O2 Telefonica, Vodafone. These companies are already working on 6G modules implementations. So yes, we talk about sensors. Now we talked about communication protocol. Now what else? It's about the cloud systems, right? So where do you store the data? Whether you store on-premise, if you have SAP or AWS systems or SQL-based database systems, whatever your ERP systems or whatever your data, that the table that you're storing in your cloud or on-premise, somewhere you need those data to be pumped from the sensors, right? Some of the very unique data point that comes from the sensor, these sensors kind of pull all the data continuously real time. So it's kind of humongous amount of data that can be collected, but we don't collect all those data, right? When it comes to use cases, we require certain parameter which is very much important for industrial use cases, and we trigger those parameter to required as part of the business requirement to push it to cloud or to push it to ERP system, right? So depending on the use cases, we pull those data from the edge or from the cloud system and do the interactions with the devices. So this is what we talk about edge computing, where let's say you have in a single plant multiple data point coming from, like you can collect those data into one single point. You can do edge computing on top of it, and collectively you pull those data required to be cloud or ERP system to push into your SAP or AWS or whichever your database has been maintained. I hope I'm not going too fast. Just let me know in between.
Yes, I think it's all right. Yes.
Okay. So in terms of data communication, there is a very, user-friendly way that need to be interacted for the end user. So analytical dashboards that helps you to analyze this. Also digital twin that gives you a twin replica of your machineries, right? So these are the major I would say, technology that industry has been using right now to front-end or to analyze different IoT parameter, right? You can have maybe 18, 20 years of the sensor data of your plant, right? But if you need to analyze those data, you need a lot of predictive maintenance information. You need a lot of predictive analytical information, and the sensor data you need is such a way, those 18 years of data, so that it can be readable format. It can be useful for your business, right? So, so basically, we create the dashboard in such a way that even the historical data can be represented using your AI and ML algorithm to give a lot of predictive maintenance, fault detection, anomaly detections related values, as well as some of the useful data point for to take the so that business can analyze those data. The past 18 years, these are the I'm sorry, some noise is coming. Maybe. Can you hear me properly?
Yes, yes,
No,
we
I
can
kept
hear
on
you,
mute.
ma'am.
Yeah.
Okay.
There was noise was coming. Yeah, earlier. I mute the participant only.
Yes. That Neeraj, you will have to help us if anybody is getting unmuted. We'll have to look into that. Yes, please, ma'am.
Okay. So think of different type of data point that continuously pumping this kind of data, and you have a historical data information on your sitting on your database, but you need to give a lot of analytical parameter in a graphical way in your dashboard so that you can take insight from those past historical data. Now, digital twin is such a thing. Let's say you have a physical model in your plant running big machineries in throughout the plant, but you can simulate those physical data in a digital way, like in a live informations in your screen. You can see what are the different parameters performing right on your plant, what is happening in your plant. So it's a live way of digital representation of certain complex business scenario or a complex machineries, and even you can trigger. So let's say you are sitting on Noida, some places, and in Bangalore or in Durgapur or somewhere, you in your plant something else is happening in terms of the data that required to be initiated and can be triggered, required to be monitored from remotely, right? So digital twin will help you remotely to analyze much more deeper level and see a physical model far from outside, right? And even taken actions based on those digital data. Now, whatever we spoke till now, sensors, protocol, the edge and cloud platform, and analytical dashboards. This is how the overall industrial architecture is happening throughout any system, whether you call SAP cloud system or Google cloud system, AWS, Azure. All these IoT platform have their own data point, right? Maybe you are using right now SAP, right? For example, or you're using AWS. So you already have existing database, whether it's a cloud or on-premise. But you have a lot of plants in different locations, which pumping continuously data and which is crucial data for your business. You can put each plant multiple edge computing protocol that can analyze those sensor point and give those data, pump it to the cloud system, whether it's SAP or AWS, and you can visualize those data, whether you name analytical dashboard or a digital twin, or in fact, you can using like it in your dashboard, you can have a much more easier interactions using chatbot as well. Um, and you can ask, for example, in your dashboard itself, you can ask, let's say, in let's say you can ask, for example, in Bhopal plant, what is the current situations for running temperature on this machineries, right? If you ask in a chatbot, it can trigger those data point and perform the query back to your IoT platform and take all this data that is already pumped here, real time as well as historical information, and give you the answer accurately, so that you don't have to be dependent on anything. You can very freely check any machinery's information that is required and relevant for you to monitor outside from the plant, very far locations. You can monitor, manage, even um, you can generate an alert if something goes wrong here. Many things you can do it on this visualization layer. So I just put up everything together till now what we spoke in a simplified way to make you understand that these are the major area where multiple n number of sensors is there, multiple type of protocol is there, and you have different platform that will interact with each other to give you meaningful insight from those sensors. Right. Now let's talk about IT and IoT related component that is currently in different use cases wise has been running towards different industries, right? So you have IT systems, whether it's on-premise, it's running on a protocol, or you are running on in a website, or you're triggering certain parameter from there, right? You have an IT system that completely handling all your ERP systems and also parameter that is business parameters and relevant tables that is important for your business use cases. You have operation systems as well here, which is your maybe a camera sensor, maybe a temperature sensor, or a motor valve, right? So all together, basically, to have a complete thought process is IoT is all together combining each and every processes in integratedly, so that you can communicate operation and IT via your IoT system, right? So the challenges mainly normally you have SCADA system, PLC or MES system that normally sit standalone. It doesn't talk to the cloud, or it might not talk to your ERP system, right? So those are the challenges normally industry face. What we do normally is we put the chipset in such a way, or we put the technology of IoT systems in SCADA to pull the data which is required from machineries to the IT system. That means on your AWS or SAP or IoT related platform that you're monitoring to that system, right? So basically overall using the API, this communication goes back and forth, read, write, you have a CRUD operation, you have read, write, update. All this operation can be performed not only the IT system, but also in OT system. This is the main job for an IoT platform provider or IoT hardware that you're going to implement.
So can I come in here once, ma'am? The IT-OT convergence, how important is the role of network? Because most of our plants and units have a separate network for IT as well as OT. So can you just simply help us understand what kind of role does network will play here? How much we have to factor in about that?
Yes, definitely. So, for example, your IT have HTTP, some of the IP and port number as a protocol unit, right? So when you call and chipset, so I can, if you, I'm not sure if you can see my screen. This is, for example, one of the IoT sensor. Um, you can see my screen, right?
Yes, yes. Your video I can see. Yes, ma'am.
So this in this chipset, you have to write a code. We write a firmware on this chipset, and so that it can communicate to the network provider where the IT system is running. So it could be an on-premise, it could be a cloud, but there is always a communication mode to the IT protocol, which need to be triggered. via secure protocol communication methodology. So you have certificates to do the communication for IT system via API. Those API will be triggered from this electronical chipset, which has your sensor data and which has also you can write it. So if I go back here, so here I was talking about the protocol, the MQTT, you have HTTPS, you have AMQP, you have CoAP. Most of the time, the communication protocol, either HTTPS or MQTT, that has been widely utilized. And if you have network, let's say you have a 5G network or you have 4G network, SIM-based network, everything can go via internet to the API via the network reliable communication to the IT system.
Okay.
So
So I'm
basically
sure you are going to because then that is going to give us some challenge for related to cybersecurity as well, because these edge sensors, when they are having that capability, so I'm sure you're going to look into that aspect as well.
yes, definitely. I will cover a few of the points. So cybersecurity is a major topic in IoT as well as in IT system. So if you see the cloud, AWS or SAP system where it has been running complete IT stack, I hope you can hear me. My voice is repeating.
Yes, I can hear you. I would request participants to kindly keep your mics on the mute.
So
Yes,
yes, thank you. So security protocol is one of the major thing that is required to be very much integrated with your IT as well as the communication methodology. So cybersecurity comes on a different layer, in a hardware layer, firmware layer, as well as in the network layer. So when it comes to hardware layer, that means how your chipset is integrated or a proof uh, that it will not hamper or it will not communicate any other system. Firmware layer is something where you're writing the code on your chipset. So in the chipset, any API, the protocol call goes in and out. That firmware code has to be proper certification that has to be implemented so that the secure protocol communication with IT system happen without any interruption or without any hacker proof methodology. So there are a certificate that calls goes back and forth via the API. The same methodology will apply also from the firmware level and the hardware level, which gives you a lot of freedom to have a secure communication with the IT system, remote system, as well as different hardware. So I just spoke about three topics, but it's quite a big topic, I would say, when it comes to cybersecurity. And technically, I think if you want a little bit more details information, I'll be happy to extend after this class. So, Chanda side, is it okay?
yes, please continue, ma'am. Yes.
Okay. So overall, the bigger picture is to implement different computing methodology on different sensor parameter in your plant or in your machineries or wherever the data is important for you to be captured, I would say. Now, even the AI is not only possible on cloud, also on edge. That means on the IoT devices, you can write a lot of AI model that will perform on the hardware level. And this will help you to reduce the cost on the cloud as well. So on edge, you will be analyzing all the sensor data to take the smarter decisions. And then you will gonna move to the cloud and the analytical segment, where the digital analysis and the physical model of your manufacturing or plant information can be triggered to your from hardware to the digital segment. So overall, I would say the complete ecosystems rollout in a different use cases can be implemented for different industry. I pull out a couple of use cases for logistic, like any kind of GPS parameter, telematic information, as well as to real-time anomaly detection, even via image processing. You can detect some of the anomaly or threat that is happening on the plant or machine level. You can implement a lot of image related model that can trigger certain alert as well on the plant. You can not only image, even you can connect with the sensor to take the smarter decisions along with the image and the sensor. Before something happen, you can even predict if this goes wrong, this could be happening later point. So somebody can get alert very prior um, on on certain situation, right? And even, for example, a failure of a vibration data for a rolling mills or predictions for those parameter can be triggered via the sensors. So in terms of safety, for example, heat stress map can be triggered throughout a plant. If you have, there are different camera sensor that can trigger green, red, and yellow zone by the heat all and around of the plant, which will give you an information about gas exposures as well as the heat stress throughout the environment. And it can trigger to your dashboard. It can give an alert to security as well as the the business person to take some actions on top of it if something goes higher to the limit. Emission logging is another parameter which is currently by almost many industries is looking for the CO2 emissions and different environmental emission parameter for carbon credit as well as the emission logging reports can be triggered as well from this sensor parameter. So I just pull out this, I would say 6 use cases. But yeah, depending on the requirements and things, we can talk more in question answer segment. So this overall architecture I spoke sometime back, but I just want to review that every industry is right now looking for industrial IoT implementation only via this methodology, right? So you have sensors, you have actuators. Sensors gives you data, actuator gives you to trigger certain actions on top of it. And you need an edge gateway to pull those data and to talk to your machineries as well. That means to trigger the actuations. So on edge gateway can connect multiple machineries, multiple sensor informations into a single place. From the edge, you can collect those data via protocol, network protocol, as I told, the secure way of communication protocol that will pump the data to the IT system, IoT platform, could be an SAP system or AWS or an Azure system. You can pump this data and then you can see the dashboard and digital twin with your machine learning algorithms, with the predictive maintenance, anomaly detections, and many more. So this is overall industrial IoT 4.0 structure that is widely been utilized in many industry. So some of the IoT pilots, highly impactful use cases, I just pick it up for starting from predictive maintenance, conversion optimizations, and utility monitoring, fleet air tracking, emission compliance, and safety. So as you see, a couple of use cases, probably you can see if you have any questions on this point, please you can ask also right now.
There is an interesting use case in the worker safety monitoring is related to variables for stress. Um, how can we monitor the stress level? Because okay, heat, gas exposure, and some moving equipments, those kind of monitoring we do have features, but that's a interesting use case. Can you throw some light on that?
Yes. So there are sensors which gives you blood pressure as well as the heart rate information and body temperature, based on and the count of steps that you are moving from a normal to casual and different occasions, right? So this parameter we analyze in our machine learning model, and we give a kind of rating that this much stress you have, you're relaxed or you are highly medium stress or highly stressed. So um, depending on this physical parameter like body temperature, heart rate, the breathing, SpO2, and the pulse, right? And then as a worker safety level, you can have. So I can show you one of the chipset that I have. It's a very small chipset. I'm not sure you can see here. You can see the rays from this line it goes. So you, as a worker, you can wear as a wristband, small wristband here, and those data can be pumped to the edge. So I'll go back here. So let's say all this SpO2, heart rate, temperature from, let's say, 1,000 worker in the plant is coming to the edge, but there are, I would say, 50 or worker, their heart rate always higher side, and there are few worker is coming highly stressed. So you can take actions from the edge to your cloud platform, and you can get those name who's wearing those wearables in the workers uh, in those plant, and you can take actions on top of it. So this is one of the use case. This is one of the use case, I think, for worker safety in mining as well. Quite interested for that.
Yes.
How do you detect roller motor wear early? What kind of sensors you are using?
Roller motor, I think there are actuators as well as trigger sensors. But yeah, I think I have to check the complete scenario properly, which can trigger each cycles and can pull those data via the edge as well.
Thing is that we don't know about the motor or roller unless the thing stops and we physically check. Motor is dismantled, then it is checked. But without doing that, is there any sensors which can detect all these things in running condition?
The cycle sensors can be triggered. So each cycle that moves can be fitted in a particular chipset and can trigger those parameter. But yes, I have to see the actual scenario in the roller motors, the make basically, which make it is and how it is being currently handled.
Ma'am, can we detect the faces? Suppose unwanted persons are entering inside the plant. Can we detect them and stop automatically?
Yes, it's completely possible. So ID via the face detection, we have algorithm as well. You can put a camera and connect the lock of the door to be open only via the authorized face. If any unauthorized persons comes or something trigger to trigger and security alert also is possible.
What is the response time of that system, madam? Because in our case, number of hundreds of vehicles are entering the plant simultaneously.
Hmm. No,
So how can we restrict that unauthorized entry when so many number of vehicles are entering at the same time?
same time means
Yeah.
same gate.
Yeah, madam.
Same gate, multiple vehicle is coming.
Yeah.
vehicle number, or you need human face detection?
Human face detection, madam.
Inside vehicle to check the, I have to see the scenario, but I was talking about in a gate where you are in front of, your face is in front to open the gate. But if you have a wide entry place and multiple people are entering,
Yeah.
and then and there you want to stop, then you need
Yeah.
always closing and opening mechanism first to
Yeah.
restrict. And then the trigger system need to be channelized. So wide places you can trigger, but you cannot stop them. So in
Okay.
closing and opening places like a door has to be there first. And yes, face detection for a particular human being, we have model gives 98 to 99% accuracy to 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 trigger that person's identity.
Okay. Okay. Thank you.
Ma'am, can you give more insight on edge gateways? I mean, like you said, ki data from sensor actuator get into first edge gateway. Thereafter, it goes into that IoT platform. So, what does this edge gateway consist of? Matlab, right now in plant, the data from sensor actuator get into PLC, and from there do the necessary action. This edge gateway is another thing. What does it consist of? So that it makes data usable for IoT platform. The hardware and software, what does it consist of?
Yes, so the sensors is a hardware. It could be your motor actuators, it could be a temperature sensors. Let's say you in
Right.
your plant you have more than 500 motors actuators, and you want to shut down on a certain temperature. If it is goes high, the first 10 you want to shut down then and there, right? But every time all those, just imagine this is like getting multiplied, right? All those sensor cannot talk directly to the plant. It will be like too many calls is happening, too many API calls is happening to the IoT IT layer. So instead of that, we do single channelized way where the edge one hardware will be the edge is nothing but like you can see the broadband connection like
Yes.
same way in a broadband it's a hardware where we will be having a secure communication protocol with the IT system. So all these 500 motors will talk to the edge, and from there we will be writing business rules here like firmware, everything has to be coded. Then which is important, if this many trigger is happening and this threshold goes high, then I should inform the IT system, then it will call. So always we recommend not to call every time to the IT system. It is not recommended at all. Depending on business use cases, we have to implement on edge protocol as well as on sensor, then trigger those data or to the platform to revert back or to shut down motors, everything. Then this goes to back and forth, this call basically. So to your question, edge is nothing but like a broadband hardware where we'll be coding in terms of which data to be collected and pump it to the IoT system.
Yeah, okay.
Mr. Abhay is asking question. Abhay, you raised the hand. So are you asking any question? You want to ask any question? I think by mistake he must have raised. Yeah, sorry.
Okay. So basically, there are a lot of deployment challenges. I mean, everything, I mean, suddenly we should not implement these use cases until unless definitely there is significant ROI. So always the recommendation is for the to pilot run for 3 months for certain use cases, and see also how the data. Definitely, there are a lot of when you implement a kind of product or a service in a different model methodology, we follow design thinking methodology, right? The similar way, we first, which are the sensors, which is relevant, which set of user is required to be implemented these use cases. It's always required to be find out and channelize those points first, and then after the implementations, see 3 months of time how the data get collected, how much it makes impact to the business, and how it's been useful for later point also as a KPI, and in terms of cost reduction, in terms of energy savings. There are a lot of KPIs that you can we can measures via the IoT systems, and then best practices we can follow according to that. So there are legacy systems, which is your standalone ERP or cloud or integrated cloud system. There are cybersecurity protocol, which require certifications and different layer of certifications from the hardware, firmware, as well as the on-edge communication module network layer, and also the resistance, right? How your pilot will be running, how we're going to scale it after 3 months. One plant, few machineries now talking for 3 months. We are getting good, useful KPIs out of this 3 month, right? Next, in the same plant, this many machineries, if we connect, how the plant will be maintained and managed, how the KPI will be driven, what next plant we can implement the same similar kind of use cases, or how we can do the scale, so that in global level, I mean, as a global level, we can drill down and see many plant informations, many plant related digital parameter informations. So this is like a kind of best practices and digital deployment challenges. I just want to put it together when it comes to industrial IoT implementation.
So we have one small query in the chat box as well. I'm not sure if that has been discussed because I was in a minute out of conversation. We have a user who is looking at the to understand the cost aspect if a predictive maintenance for say around 100 motors in a rolling mill has to be installed. So would it be possible, or do we need to discuss it separately?
I think it's better if we can discuss separately, because there are parameters that has to be checked when it comes to predictive maintenance.
Right. Yes, Mr. Aveji will share the connections with you. Maybe you can connect with ma'am and then discuss. Yes, ma'am, please.
Yeah, sure. I look forward to help you even after this training for further. So couple of use cases that we have implemented for manufacturing as well as automotive segment. So this is our devices, IRA, which is kind of take 16-bit CAN protocol, and as well as we have IoT logger to take all the sensor parameter, even for edge computing. We have clusters and AI ECU for automotive and BS6 engine, and for emission monitoring platform, a dashboard that we have been working with a few of the manufacturing unit. So basically, I after the sessions, I was just trying to put all together in terms of sensors and the platform that in Things Alive we have been doing past 5 years. And all these IoT devices gives a very unique part of data, like error code, fault code, emission parameter, real-time informations, edge computing parameter as well, control system informations, and many more. And all this parameter via the protocol and communication module that we have in place, we connect with our dashboard. From the IT system to the dashboard, we see all those parameters basically. So yeah, the future is all about a new technology that will help meaningful, uh, that will build meaningful use cases for industry. So it's not only the technology; it's also about whether it's a useful and whether it's a required at that point. 6G came doesn't mean we cannot use 5G, and I mean there are a lot of things is happening in terms of technology, but we always need to identify what is the right technology in the right place and right use cases that brings the most ROI, and implementation wise that will be helpful. So yes, these are the future trend. We are we are 4G, 5G now. Has been already working on 6G. We have blockchain for secure communications and many other um, uh, possibility to implement, and many use cases that can be implemented out of this technology. And yes, this technology can be integrated with the IoT and the industrial IoT sensors, parameter communications that will be useful. So yeah, from here.
In IRA, the sensor and hello.
Yes, yes.
In IRA, how much MII content you are giving?
Can you come again?
In IRA devices, how much MII content you are providing, like Make in India content the government is pushing about?
Currently, all the sensors that we are taking either from Taiwan or from Germany, and definitely few parts are from India, and everything in-house making. Just 1 second. Let me share my screen. So we have been doing complete in-house development from the hardware design as well as yes. So we choose the complete sensor. We choose each and every sensor informations that is required for our use cases, and then we design in-house. This is completely in-house design and manufacture in-house. We have firmware designer and firmware hardware implementations engineers. We have application as well developer and AI engineer. So we are pretty boutique solution provider. We find out the use case requirement, drill down the problem statement, and we do complete in-house. We don't do anything outsourced in terms of hardware implementations as well as the software and the communication methodology side of it. But yes, in terms of this chipset design we are doing, but few parts are coming from different locations or different countries. So we assemble them in-house based on our requirement and use cases. So this is one of the IRA device that is we design. This is for end of line, which is little bit bigger chipset. I hope you can see my screen.
Yes.
Yes.
Yeah, so this goes to end of line in terms of communication methodology. IHR engine, right? IHR engines, they're in the manufacturing plant, they've been using these devices to analyze the engine health parameter during production and after production during the servicing segment as well. And we have a couple of communication modules which goes to this chipset. So depending on the edge computing, we have Modbus related edge computing broadbands as well, which kind of collect all those sensor parameter. With the if sometime plant required multiple input and output parameter, we change the hardware in our office, and then we change the broadband connections and the communication protocols as well.
Okay.
So
Do you have any kind of any average percentage at how much MII you are like 70%, 80% like that?
it's more than 70 definitely, but yeah, we haven't done any kind of MIS like percentage calculations, I would say.
Okay. Okay, fine. Thank you.
There are certain
Yes.
questions on the chat as well.
Yeah, maybe we can take some questions now.
We can take it at the end, or shall we take it now?
I think we can take the
Shall I tell you?
questions now.
Yeah.
Yes, yes.
Chandraji, you can read that.
I think it has been
Person has
really
raised it. They can also ask the question also. It's not
Yes.
they just chat. They've kept the chat because I would rather say that they can also ask the question. They can unmute and then ask. He's saying I'm not audible.
a lot of questions has been occurring, interactions is going on. So if anybody else is having some more questions, Raj Kumar ji is having a very specific technical questions. He has a suggestion. How about using Raspberry Pi 5 module? I think it could be cost effective. So I think that's a research topic that you have thrown out there. So it's not possible to take up that in such sort of span. Yes, I'll definitely share ma'am's contact details and LinkedIn Connect. Why MIA is coming, ma'am, in the discussion is because we are, mandated with our purchase rules that when we procure, we have to look into that. So that's why probably Avinash ji was, having that discussion.
There's one more question there from Abhaya ji. He's saying that what is the possibility of cyber attack on such installed systems? Beside, what is the life cycle of such installed system, and it's disposable after end of life cycle with environmental sustainability point of view.
So
Maybe
cybersecurity
I need to
aspect.
understand.
Yes, please, ma'am.
I need to understand the question a little bit deeper way. But yes, cybersecurity for IoT system is a very, very important topic in all around throughout the implementation as a solution, as well as hardware, software, firmware, communication, network protocol wise, every places. So it's a very, very important topic. So when it comes to use cases, we have to understand which are the system it is interacting, which is the communication module, what kind of chipset you are selecting, in terms of firmware implementation, how the communication is going to the different systems as well, right? So what is the certifications that is in place in terms of protocol calls that is going from the hardware to the software layer. So yes, it's very, very important topic, but yes, technically it's very deeper topic to talk about.
We'll try to conduct one for the cybersecurity specifically, because that requires some more discussions. All right. I understand I have to be bad person here because I need to respect the time as well. I promised to take out 60 minutes. I have already taken 65 minutes. So I'm going to pause the session here. But yes, knowledge sharing and the discussions, and if you have some requirements, can be continued after the session as well. That's not an issue. Let me invite now that our leader is here, Mr. Sanjay Dhar, who is the Chief General Manager as well as Executive Director HR L&D in SAIL, and sir is currently heading the L&D vertical of our organization. So he has been pioneer and driving a lot of digital outreach initiatives, and these knowledge bite sessions that we are conducting is one of his one of many ideas that he has uh, set in our organization. Sir, it has been, just to give you an idea, it has been a wonderful engaging session, and Madam Sulekha Day has from the discussion itself was evident that she has taken out a lot of time from her busy schedule to prepare a custom content for specifically for sale. From what I could see, lot of theoretical aspects were merged with practical solutions, and how SAIL can, leverage those solutions with some of the use cases that she has presented. So it was a wonderful, wonderful insights from her. So let me invite you, sir, with your, thoughts as well as guiding words.
Thank
Sanjay
you.
sir, please.
Thank you, Chandra. And at the outset, I'd like to thank NASCOM and Neeraj personally for your support. And I'd like to thank Sulekha ma'am for really taking out time. I mean, you have epitomized the kind of collaborative setup ecosystem that is being developed by NASCOM for taking the whole nation forward. And we are part of it. We are all part of it. And that's why we are connecting. I'm sorry, my apologies for not joining earlier. There was another urgent meeting that I could not close well in time because, again, it was a technical meeting, so I could not close it in time. But whatever little I could pick up towards the end and the kind of feedback that I've got from the others, these are the kind of interaction that we need for people to stay connected day in, day out with new developments in the field, because we are all struggling to figure out how do we really embed new technologies into our processes. And right now we're in the midst of a very major digital transformation journey. And at the end of the day, it boils down to the fundamentals. We really need to get those building blocks in place. And I'd like to thank Sulekha ma'am for giving such a wonderful interaction and addressing all our queries. And the fact that people are asking about MII, please understand it arises from the fact that, we are trying to say, okay, we want to use the solution, but will our procedures, procurement procedures allow it? So that's why the query is coming up. And these kind of interactions really help us to make intelligent choices on how to take it forward. So once again, thank you very much. And I'd like to thank all the participants for their time. It's a very dicey schedule for us. We have a chairman's review going on parallelly. So that has affected some people in terms of their ability to attend. But we look forward to more such interactions. And once again, thank you for your active participation. Thank you, Chandra. I think we can close it here.
Thank you. Thank
Thank
you,
you,
sir.
Sanjay sir.
Thank you for your all-time support, sir. Yes, no words can be sufficient for, such a wonderful and, such intriguing discussions that we had today. A lot of interactions were there, and we look forward to connecting again. So once again, thank you so much, Sulekha ma'am and Neeraj ji. Thank you, Sanjay sir, as well as Tanu sir, and all the esteemed senior leaders who have taken out time from your busy schedule to join, and young mentors. These are just nuggets that we are organizing for you. And for the next 30 days, it is expected that you will at least have 1 or 2 sessions with your mentees and try to explain them the IoT's concept, some of the use cases. And if they are interested, maybe we can connect with our SMEs for taking the solutions forward. So on that note, thank you so much, everyone. And now we can disconnect. See you again next month, Saturday at 4 p.m. Thank you so much.
Thank you so much,
Thank you,
everyone.
Chandra ji. Thank you.